Human beings in ancient times thought the ocean would vanish into empty space at a specific edge. Fast forward to today, and we now grapple with an even bigger question. Is the universe so enormous that it must have a boundary? Through James Webb Space Telescope, mankind explores cosmic depths never achieved in human history, which force us to reassess our knowledge about space as well as time and existence. With its groundbreaking innovations, would the revolutionary telescope uncover the limits of our observable universe? Do we search for the universe's boundary, or will additional space-time discoveries bring more unexplained phenomena to find the universe's edge? Throughout human history, people have wanted to establish clear limitations of their known realms. First, it was the horizon. As time progressed, people measured their understanding through both horizon marks and starlight observations. Today, our telescopes help us observe an immense universe reaching beyond 92 billion light-years as its diameter. The James Webb Space Telescope, built by humans, serves as our most sophisticated telescope ever and simultaneously enables us to witness ancient light arriving from billions of years in the past. But even with this extraordinary capability, the question remains: does space-time feature a precise boundary? Every scientist working at present acknowledges that our observable universe does conclude at a specific edge. Scientists measure the observable frontier through the combination of cosmic light progress and universal time duration. Our ability to view celestial objects depends on how long infrared light moves through space, because the universe began at a specific time. Our perception ends at this constructed horizon, which remains beyond view. The boundary which marks the edge of the universe may extend somewhat further than what we have been able to observe. The visible horizon masks additional galaxies which potentially exist together with stars and phenomena that science has yet to measure. What the James Webb Telescope reveals about the beginning of time. The James Webb Space Telescope operates as a time-traveling instrument to detect early galaxy emissions from the period after the Big Bang. Scientists designed the James Webb Space Telescope specifically to research the dark ages of cosmology, which began before full star and galaxy development happened, but it has previously challenged our current understanding. The telescope discovered mature galaxies which existed less than 200 million years after the Big Bang, instead of revealing unpredictable young proto-galaxies. Scientific teams studying ancient galaxies with the James Webb Space Telescope observed a total of 6 galaxies that proved extraordinary through both their complexity and their large dimensions. Scientists relied upon existing cosmic evolution theories, which indicate massive galaxies should form after the universe reaches a much later stage. These proto-galaxies became history through direct evidence gathered by the James Webb Space Telescope's infrared sensors, which monitor celestial signals from the universe's beginning. This raises profound questions. Were the dark ages of the universe an actual historical reality? Did the apparent dark ages really exist? Or did scientists simply create a timeline to explain what they couldn't explain? New theories about cosmic development must now be considered because mature galaxies, who have been evolving for only 500 million years, reveal faster and more intricate patterns of cosmic evolution than researchers previously envisioned. Redshift and the mystery of time. One essential instrument for James Webb Space Telescope to study the universe involves observation of redshift behavior. Throughout the universe's expansion phase, light moves across the spectrum from objects at long distances toward redder wavelengths. The greater the redshift, the farther away, and the older the light source. Through its observations, the James Webb Space Telescope discovered galaxies which emitted light-holding redshifts above 10, indicating they existed during the universe's early age, when it reached only 2% of today's size. These ancient galaxies defy expectations with their detected features that challenge our historical understanding of the young universe. Light detection techniques, utilizing spectroscopy, showed definitive evidence which supported these observations. Science teams examining light waves from these distant galaxies discovered their chemical makeup and their dating characteristics, which showed an unexpectedly advanced early universe nature. The newfound light emissions from the early universe extended the universe timeline beyond our current understanding, indicating we might need to explore previously unimagined phenomena from this period. Why finding the edge is so challenging. Using the James Webb Space Telescope, scientists can see deeper into space than in any previous occasion, but they still face an overwhelming challenge to determine the universe's actual border. The challenge emerges from physics limitations related to light movement through space and time boundaries. Our distant observations arrive over billions of years until they reach Earth, allowing us to view house images from the past rather than present-day views. From Earth, we see the Andromeda Galaxy existing as it appeared 2.5 million years ago in the past. Universal visualization allows us to see the cosmos in this manner. From billions of years ago, James Webb Space Telescope sees the galaxies, while the universe has undergone expansion throughout the intervening time. Scientists pursue the identification of cosmic areas, much like actors drawing lines on an expanding ball. The expansion process generates a dynamically shifting boundary that challenges us to establish concrete boundary definitions. Beyond uniform expansion, the universe exhibits other patterns of growth. Different cosmic regions experience varying expansion rates, which increase the system's complex mathematical composition. Studies of the universe show an irregular expansion pattern, which points toward an existence of complex dispersed elements beyond human comprehension of current cosmic structures. Infinity and the search for boundaries. The James Webb Space Telescope discoveries confront scientists with the fundamental question of establishing concrete boundaries within the cosmos. Science may prove the universe keeps extending without limit. The boundaries we observe turn out to be boundaries that guard new investigative opportunities. James Webb Space Telescope observations, when focusing on quasars, show how these galactic nuclei are brightened by supermassive black holes. The telescope detected a quasar active within a galaxy only 570 million years after the world's creation during the Big Bang. Galaxy M-Ground's supermassive black hole holds 10 solar masses as it produces light which surpasses the brilliance of all known stars by numerous trillions. University scientists face a challenge regarding how an enormous structure could develop within the first 570 million years after the Big Bang. Design discoveries of colossal black holes surrounded by hyperluminous cores drive us to challenge our current principles about universal development and temporal phenomena. The James Webb Space Telescope continues to redefine our understanding of exoplanet observations in its mission. A major research discovery from James Webb Space Telescope involved HIP 65426b, which scientists determined to be a gas giant 12 times bigger than Jupiter, at a distance of 100 times farther from its star than our planet's distance from the Sun. The James Webb Space Telescope demonstrated direct imaging of this planet to show how it detects unconventional phenomena despite extraordinary challenges. Etienne Bedos and their colleagues demonstrated with their findings that infinite diversity likely exists in the universe, which makes the pursuit of an edge an impossible mission. Science exploration through the James Webb Space Telescope demonstrated why human curiosity represents a critical driving force. Science serves to uncover new questions through exploration rather than seeking definitive solutions. Our exploration of space gives us both information to understand and respect for the miracle of the universe. Thank you for joining us. Don't forget to hit the like button, share this video with fellow, and subscribe for more explorations. Stay curious, and we'll see you in the next one.